All right, welcome back to 9.2, or the first lesson in Unit 9. We are solving trig equations algebraically. So we did a little bit of it in Unit 8, simple trig equations. We're going to look at slightly more complicated. Not that bad either, but it's definitely going to be longer. Okay, so we'll see. Okay, so here, this is the warm-up question. This is the kind of equation that we did in Unit 8. So let's quickly do this. It says sine theta is equal to -1/2 for theta between 0 and 2 pi. So hopefully you recognize that this is a special triangle question. Okay, 1/2. So we can draw a special triangle quite easily here because it's 0 to 2 pi. So we are working in radians. So this is going to be pi over 6, pi over 3, 1, 2, root 3. So sine is opposite of hypotenuse, therefore 1 is the opposite side, and therefore the reference angle is going to be pi over 6. Okay, now because the ratio is negative, we know sine is negative we know the sine is negative in quadrant 3 and 4. So our two answers will be here and there. So here's my first angle, and this will be my second angle. So theta 1 would simply be pi plus the reference angle of pi over 6, which is going to give us 7 pi over 6. Theta 2 is going to be the reference angle being pi over 6, therefore it's going to be 2 pi minus pi over 6, and that is going to give us the answer of 11 pi over 6, and here are two answers. Okay, so that's what we did in Unit 8. Simple trig equations. Okay, so let's take a look at what we're going to be doing today. Okay, so first of all, this is still somewhat simple, but now we're going to write the general solution. Okay, so this is something, well, the terminology is new, but it's not really new. Okay, so let's see. It says use algebra to solve the equation 6 minus 5 sine x equals to -1 plus 3 sine x for the angle from -360 degrees to 0 degrees. So to solve this question, this is just simply like a linear equation. We need to isolate for x. So in this case, we isolate for sine x. So I'm going to move all the sine x to the right and all the constants to the left. So I plus 1 on both sides, I get a 7, and I add 5 sine x on both sides, I got 8 sine x. Divided by 8, I get 7 out of 8 is equal to sine x. Now I can find the reference angle by taking the inverse sine of 7 out of 8. And this would be, I don't know the answer, so I should get, we are in degree mode, so I need to change back to the degree mode on the calculator. Okay, so that's also a common mistake that you forgot to change the modes. Okay, so now this should be 61 degrees. Okay, so that's the reference angle. Because we're looking at sine being positive, so we know the answer is going to be in quadrant 1 and 2. Okay, so we're looking at this angle and this angle, right? Because we are looking from -360 to 0. So this reference angle is simply 61. So theta 1 is simply going to be, okay, so first of all, I'm just going to put negative sign there because I know I'm rotating clockwise. And really, to find this angle, if you don't think about signs, is simply going to be 180 plus 61. So this is -241 degrees, okay, if we round to the nearest degree. Whereas this one, again, the reference angle is 61. That means theta 2 is going to be, again, negative sign in the front. But to find out what this is, you simply take 360 minus 61. And that you will get -299 degrees. Okay, so those are the answers for the domain from -360 to 0. Now it also says we want to find the general solution. So the general solution is simply means like what other angles would also work if it's not within this domain, right? We know every time once we rotate one extra rotation back to that terminal arm, the answer is going to be the same, right? Because it has all the same properties as -241. It's just that we rotate once more. So to find the general solution, you simply take this answer plus the period times n. Okay, because 360 is the period, because that's one for rotation, and n is just integers, right? Because you can rotate clockwise, then in that case you subtract 360. If you rotate clockwise twice, then you minus 720, so 360 times 2, and so on. If you rotate counterclockwise, then you add 360 instead. So in this case, it will be similar, but it will be negative 299 instead of negative 241 because that's the answer in this quadrant, plus 360 times n. And now you just need to define that n is the element of integers, and those would be your general solutions. Okay, those would be your general solutions. Okay, so take your particular answers, these two, plus the period times n. And n is the element of integers. Okay, so let's look at the second one here. This time, this one is slightly more challenging. Okay, so what we've done so far in Unit 8 and the first example right here is that we are dealing with sine x, cosine x, tangent x. However, in Part B, we're dealing with now tangent of 3x. So it's not just tangent x. So how do we deal with this? It's actually quite easy. What you need to do is this. I'm going to say let a equal to 3x. In that case, my equation becomes tangent of a is equal to negative 1. Okay, this again is a special triangle. Now we're working with radians. Okay, we're working with radians. Tangent is equal to 1 when, okay, so if you recall your special triangles, pi over 4, 1, 1, root 2. So opposite of adjacent is 1 over 1, so that's just 1. Now we know tangent is negative in quadrant 2 and 4. So I know the reference angle is going to be pi over 4. Okay, so now I know the answers are going to be here and here. So here's my A1, here's my A2. So now I can find A1 easily because I know the reference angle is pi over 4. And this is pi over 4. So A1 is simply going to be pi minus pi over 4, which is going to be 3 pi over 4. Okay, and I can find my A2 quite easily as well because this is going to be 2 pi. You know what? I'll finish one at a time. Okay, so A1 is 3 pi over 4. However, the question was never, so I won't name this A2 anymore. Okay. However, the question was never asking about A. It was always about X. So once I find my A1, I can find my X1. Because I said that A is 3X, that means 3X1 would have to equal to 3 pi over 4. Right? A is equal to 3X. So this is A1. It's the same as 3X1. And 3X1 is equal to 3 pi over 4. Therefore, I can solve for, so I will move this away then. I can solve for X1 by dividing both sides by 3. 3 pi over 4 divided by 3 is simply pi over 4. Okay, so here's my X1. And now I can find my X2 because we can find more answers by adding the period. Okay, so now the period is, well, first of all, it's tangent. So usually the period is going to be pi. Okay, recall from Unit 8. The period for tangent is pi. However, this is not just tangent x. This is tangent 3x. So the period is actually going to be pi divided by b. So it's going to be pi over 3. So x2 is going to be pi over 4. Again, that's your first answer, plus the period, so pi over 3. And this is going to be 7 pi over 12. Okay, you can just make it the same common denominator. That would be 3 pi over 12, and that's 4 pi over 12. Add them together, you get 7 pi over 12. And we want the domain to be 0 to 2 pi, so we will have to continue. So x3 would equal to, again, the next answer is 7 pi over 12 plus the period. And pi over 3 is 4 pi over 12, so then this is going to be 11 pi over 12. This is still less than 2 pi, so now we're going to keep going. We're going to find x4. So that's 11 pi over 12 plus pi over 3. This is going to be, what is this, plus 4, so 15 pi over 12. Okay, and we can find x5. Same thing, 15 pi over 12 plus 3 pi over 12. And, pi over 3, which is 4 pi over 12. This is going to be 19 pi over 12. Okay, and we will continue. We have a lot of answers here. We can find x6, 19 pi over 12 plus pi over 3. This is going to be 23 pi over 12. This is just shy of 2 pi. So that's fine. We have 6 answers here. So all these 6 answers are correct. Okay? Now, we're going to move on to second case. Okay, this is the case where angle is in second quadrant. Now, let's move on to case 2. So this is case 1. This is case 1. We can have case 2, where the angle is in the fourth quadrant. Okay, so this was already x6. So I'm going to call this A7. And this is pi over, what's the reference angle? Pi over 4. Okay, so now our A7 is simply going to be 2 pi minus pi over 4, which is going to be 7 pi over 4. Okay, 7 pi over 4. Right, that's right. Okay, and now because A7 is equal to 7 pi over 4, we can then find we can say 3x7 is equal to 7 pi over 4. Now divided by 3, you should get 7 pi over 12. And that's your x7. Now hold on a second. Wait a minute. 7 pi over 12. Don't I already have that answer right there? 7 pi over 12? And that means if I continue to find x8, I simply take this plus the period, which was pi over 3. I would just get the following answer. And so on and so on and so on. So really, these 6 would be the entire full set of solutions. That's it. You have 6 answers. Which also makes sense because if you think about this, from 0 to 2 pi, you should have 2 answers. Okay, that's one full cycle, you should have 2 answers, right? When I say one full cycle, I mean like one full rotation, right? You should have 2 answers, one here, sorry, not there, one here and one there, right? For tangent, you have 2 answers, one there and one there. So for 0 to 2 pi, you should have 2 answers. Now this is compression by a third, which means we can actually rotate this 3 times. So if one full rotation has 2 answers, that means 3 full rotations would have 6 answers, right? 6 answers, which makes sense. 1, 2, 3, 4, 5, 6. Those are our 6 answers. So we don't actually, in this case, we don't need to consider case 2 because we already found those 6 answers. However, this is only the case for tangent. Okay, for sine and cosine, you would actually have different answers. So be careful. You should always do both cases, just to make sure that you cover all the answers, okay? But really, we don't need to have this anymore, okay? Because we already covered in this piece right here. We have our 6 answers right there. All right, that was a lot of talking for me. Now it's your turn to try to do the next page. There are 3 questions. You should be able to do at least the very first one, part A. And I'll show you how to do the other 2 in a second, okay? Okay, good luck. Okay, let me backtrack a little bit here, back to the previous question here. It actually also asks for the general solution, which I have not done that yet. Okay, so to find the general solution is actually quite easy. Again, it's your enter. So the first one, pi over 4, plus the period times n. And this actually generates all the rest of the answers if we say that n is the element of integers. And that would be your general solution. We only have one general solution in this case because your x1 actually generates the rest of it. You see, that's why we rejected this x7, because that's actually part of the solutions that we can get from x1. Okay, so going back, or I guess moving forward to the practice question. Hopefully this is what you got. You should get negative 225 and negative 315 degrees, and then to find the general solution, you simply take those 2 answers plus 360 times n. Now again, this case you actually have 2 general solutions because you won't be able to get one answer from the other. So by adding the period, okay, so you actually need to write down both of them. Okay, so again, general solution is always those 2 answers plus the period times n. Okay, continue with part B. I'll show you this one here more slowly, I suppose. So here it says 3 secant 2x minus 7 is equal to negative 3 for negative pi to pi, and then write the general solution. Okay, so first step, we should solve for secant 2x. So I'll do this quickly here. You should add 7 first, so you should get negative 3 plus 7 is 4, and then divide by 3, so 4 over 3. Okay, now this is secant. Remember, this is the reciprocal of cosine. So be careful. Again, this is a common mistake. Don't do this, right? I mean, this means secant is 1 over cos. So this really means 1 over cosine 2x equals 4 over 3, which means cosine 2x is equal to 3 over 4. So this is what it is. Okay, be careful, be careful. I know a lot of people do something weird like I can't remember what you do anymore, but be careful. It's not cosine of 1 over 2x equals to 4 over 3, something like that. I think some people do it like this. Just be careful, okay? You flip the entire cosine. Okay. All right, so I'm just going to erase everything, and I'm just going to say, so once we get this, we should have cosine 2x is equal to 4 over 3. 3 over 4. Okay, so now we can solve this. Remember, we said that let a equal to 2x. That means cosine of a is equal to 3 over 4. We can find the reference angle by taking the inverse of 3/4. You should get, this is not a special triangle, so we will have to use a calculator. We are in radian mode, okay? So again, now you need to change back to radian mode. I need to change it back. I think I remember this. Divided by 4. This is going to be 0.72. This is the reference angle. Okay, now we can find A1. Then, well, because we say A is 2x, well, not yet. Okay, so A1, cosine is positive in quadrant 1 and quadrant 4. So I'll say case 1. In quadrant 1, this is Q1. In this case, A1 is simply 0.72, right? That means 2x1 is equal to 0.72, so x1 is 0.36. Okay, now that's one of the answers. Now we are going to go, we're going to add the period, right? So we can find x2 by simply taking 0.36 plus the period. Period is, in this case, well, it's cosine 2x, so the period is going to be 2 pi over 2, which is pi. Now notice if you just add pi to 0.36, it's going to go beyond our domain. So 0.36, we will not add pi anymore. We will simply take away pi. This will give us a different answer. Okay, so let's see what this is going to give us. Let me do it again. So inverse cosine of 0.75, and then that divided by 2, and then take away pi. So I won't round anything until the very end. So this is going to be negative 2.78. So that's my x2. That's my x1. That's my x2. And I won't subtract another pi because it's already negative. If I minus another pi, it's going to go beyond our domain. So now I finished with my case 1. Now we're going to move on to case 2. This is where the angle is in quadrant 4 because we know cosine is positive in quadrant 4 as well. So then we have the same reference angle, okay? But our A2 is going to be now, because we're in quadrant 4. Okay, I mean, you can see this because it goes from negative pi to pi. So we can actually just go this way instead. And that means this A2 is going to be negative 0.72. And therefore, 2x1, sorry, this is not A2 anymore. We have to do this A3. That means 2x3 is going to be negative 0.72. So x3 is negative 0.36. Okay, so that's our third answer. And again, we will not subtract pi because it's already negative. If you subtract pi, it's going to be less than pi. So what you're going to do is you're going to plus pi instead. So you actually get 2.78 this time then as your answer, as your x4. Okay, so you should have 4 answers. Again, which makes sense because the period is half of what it was. So what it means is it's going to rotate twice within 2 pi. And again, every 2 pi, you should have 2 answers. If you have 2 full rotation, then you're going to end up with 4 answers. And that's why we have 4 right here. All right, for the general solution, you're going to end up with 0.36 plus the period times n and negative 0.36 plus period times n. I guess I could just say plus minus 0.36 plus pi n. Whatever, it's okay. And n is the element of integers. Okay, so that's it. Those are the 4 answers within that domain, and that's the general solution. Okay, continue. To the nearest hundredth, solve this equation. So same thing, we would have to isolate for sine 0.5x first. So sine of 0.5x is going to equal to move 1 over is negative 1, divided by negative 3 is positive 1/3. So sine of 0.5x is 1 over 3. Same thing. Okay, you can see it's not that bad once you get hang of it. you replace 0.5x with a, so we can find the reference angle, and inverse sine, we are in radian mode, perfect, so I'm also still in radian mode, so inverse sine of a third is 0.34. We can find a1, and because we are looking at angle in the sine is positive, so angles would be in quadrant 1 and 2. So a1 would simply be 0.34. This is case 1, right? Case 1. I'll do it over here. Case 1 is in quadrant 1. Therefore, a1 is simply 0.34. And then we can say 0.5 x1 is 0.34. You can solve for x1 by dividing both sides by 0.4 or times by 2. You should get 0.68. Okay, so that's your x1. And now from here, we can find x2 by taking this 0.68. Well, I guess I was supposed to write equal sign. 0.68 plus the period. Now, the period is going to be 2 pi for sine, but because the value of b is 0.5, so the period is going to be 2 pi divided by 0.5, which is actually 4 pi. So I don't think it makes sense for us to add 4 pi because clearly we are going to go outside of the domain here. So we can try to minus 4 pi, and you can try this. You will see that this is clearly outside of the domain as well. This is negative 11.9, and we only want to go all the way down to negative pi. That's clearly less than that, so we will reject this answer, and that will be the only answer for our case 1. Whereas case 2, we would be in quadrant 2. So A2 is now going to be pi minus the reference angle, right? Because it's right here. This is reference angle, and we're looking for that. So we'll take pi minus 0.34. You should get 2.8. Okay, and then that means we can find 0.5 x2 is equal to 2.8. So x2 is going to be, I guess you times by 2, so 5.6. So this is the answer for x2. Now you should check if this is actually more or less than 3 pi over 2. So I'm going to check 3 pi over 2 and see what that is. 3 pi over 2 turns out to be 4.7, and 5.6 is more than that, so we will have to reject this answer. However, we can use this 5.6, take away the period, and see if this fits in the domain. Okay, 5.6 minus 4 pi is going to be negative 6.97, and again, this is still less than negative pi, so we will not only reject this answer, we will also reject this answer. So within this domain, this is the only answer that we have. However, for general solution, you actually need to write both, okay? Because, I mean, this is the only answer within this domain, but in general, you would have more answers. So you would take the particular answer plus the period, which is 4 pi times n, and the other one would be 5.6, that's the other one, plus 4 pi n, even though it didn't work out for this domain, but that would be the answer if there was no domain, right? If we were not restricted by this domain. And n is the element of integers. Okay, and now, so you only actually have one answer here, and you do still have 2 general solutions. Okay, that's it. We have one last example that I need to show you, and a practice question. It says, when a secondary equation cannot be solved by factoring or using square roots, okay, this is going back to math 11, we will need to use quadratic formula. Okay, second degree function means parabola, something squared. Okay, so you can see we have cosine squared 2x. Okay, so this cosine squared 2x actually means cosine 2x squared. We just write it this way instead, okay? But that's what it means. Okay, cosine squared 2x means cosine 2x, the entire thing squared. Okay, so now we can actually, to solve quadratic equations, recall we need to make it equal to 0. Okay, so I'm going to move my 3x squared or 3 cosine squared to the left because I always like to keep my square term positive. So 3 cosine squared 2x plus cosine 2x, moving the 2 over, minus 2 equal to 0. Now, if you can factor, I would factor it. or you can always, you can always use quadratic formula. I personally like to factor if I can. This one I believe is factorable. So if you factor this, you should get 3 cosine x, what do we have here? Plus 1 and minus 2. Yes, that's how you factor this, and this equal to 0. Okay, so now what this means, oh, cosine 2x, sorry, not just cosine x, cosine 2x, cosine 2x. Okay, this is going to be a long question. Okay, here we go. So 3 cosine 2x minus 2 and cosine 2x plus 1. This means cosine 2x equals 2 over 3. This means cosine 2x equals negative 1. Okay, that's what it means. So now what I'm going to do is I'm going to again break this into cases. Case 1. Okay, this is a long question. Okay, here we go. Case 1. Case 1, we have cosine 2x equal to 2 over 3. So again, cosine A equals 2 over 3. Reference angle is going to be, we're in radian mode, I believe, yes. Inverse cosine. Mostly I'll ask you to do in radian mode because you don't really use degree anymore after you learn radians. Okay, reference angle is going to be 0.84. Now cosine is positive, so we can find A1. Cosine is positive in quadrant 1, so 0.84. Therefore we can find, so 2x1 is 0.84. Therefore x1 is 0.42. Okay, from here, that will be the answer for sure. Now let's find a period first. The period is going to be 2 pi over pi, or so over b. In this case, the value of b is 2. So period is pi. So because the domain is from negative pi to pi, it makes no sense. It makes no sense to add another pi. So I can find x2 by simply taking this minus pi. You should get negative 2.72. 2.72, and that's your x2. That's perfect. Okay, and now we're not quite done yet with the case 1. Okay, this is going to be a long question, as I told you. We will now we could find A3. A3 would be in quadrant 4. Okay, quadrant 4. So then in this case, if the reference angle was 0.84, A3 would be 2 pi minus 0.84. Okay, 2 pi minus 0.84. This is going to be 5.44. That means 2x3 is 5.44. That means divided by 2, we're going to end up with 2.72. Okay, now 2.72 is still within the domain, right? You can see it's between negative pi and pi. Now it makes no sense if for me to add another pi, because then that's definitely going to be more than pi. So what I need to do is to take away pi, and you should get negative 0.42. So that's your x4. So there are my 4 answers, and that's my case 1, where cos 2x is 2 over 3. We now have case 2, and this is where cosine 2x is equal to negative 1. Okay, so negative 1 is a special case. Recall, cosine is the x value, and x is negative when we are at 180 degrees or at pi. Okay, so I guess reference angle in this case is just simply going to be pi. Okay, because that's when cosine is equal to negative 1. That means 2x, I guess I'll call this x5 now. This is going to be pi, and therefore x5 is going to be pi over 2. Okay, cosine equal to negative 1 when we are at pi, and that means 2x5 is going to be pi, and therefore x5 is pi over 2. Again, this will be answer for sure. But again, if you add pi to pi over 2, it's going to go beyond pi. So what we do is to find x6 is we take pi over 2 minus pi, and that will give us negative pi over 2, and that's our x6. Okay, so let me explain this again with case 2. Cosine equals to negative 1. We know on a unit circle, cosine is the x value, and x is negative 1 right here. And this is pi radians, and that's how I find my reference angle to be pi. Okay, and therefore 2x5 is going to be pi, and x5 is pi over 2. Reference angle though usually is not. Anyways, it's usually between 0 and pi. But okay, I mean I could really just say that 2x5 is equal to pi, and therefore x5 is pi over 2. Okay, anyways, so here are the 6 answers that you have within this domain, and now we need to write the general solution, okay? So we would have 0.42 plus the period times n, and we have the 2.72 plus pi times n, and finally we have pi over 2 plus pi times n. Right? You can see the difference between these two values is also pi. And finally, n is the element of integers, and that would be your general solutions. Okay, I told you this was a long question. You have one last practice question to do. Good luck. I'll let you try it, and I'll show you the answer in a bit. All right, the last question again is quite long. This one, once you solve for tangent, or if you move all the terms to one side, you'll notice that this is not factorable. You have to use quadratic formula. So I did tangent 2x, because it's tangent squared 2x, so it's tangent 2x equals negative b. So if you remember the formula, did I write down the formula on the top? No, I didn't. Okay, so if you don't remember, the formula was x equals negative b plus minus square root of b squared minus 4ac divided by 2a. So recall this is the value of a, that's b, and that's c. So I plugged it in, and here is my tangent 2x equals 2. So now we should have two cases. One case being tangent 2x equals to 2 plus root 32 over 8, and the other one is 2 minus root 32 over 8. To find the reference angle, you simply take the inverse tangent of that, because this is positive, so we don't need to worry about it. This is 0.76. And because tangent is positive in quadrant 1 and 3, so you see I written in blue, A1 would simply be 0.76, because the reference angle is 0.76, and the angle is in quadrant 1. So 2x1 is 0.76, therefore divided by 2, x1 is 0.38. Now from here, to find other answers, you simply take 0.38 and plus the period times, or just plus the period. And the period, because it's tangent to x, so it's pi over b. The period is pi over 2. I read it down over here. So plus pi over 2, 1.95. Again, if you add another pi over 2, it's going to be more than pi. So I start subtracting pi over 2 from 0.38, and I get this and that for these answers. Okay. Now, so that's done in quadrant 1. And if I move to quadrant 3, so then my A5 would be the pi plus the reference angle of 0.76, and I get 3.91. That means 2x5 is 3.91. Divided by 2, I got x5 as 1.95, which is a duplicate answer of the one that we have already here. So we don't need to consider this at all, okay, because we already got them. Okay, moving on to case 2 is when tangent to x is equal to 2 minus root 32 over 8. Notice this will be a negative value. So what you should do to find a reference angle, recall, is to get this value first, and this is going to be negative something. Whenever you find a reference angle, you take the inverse tangent or inverse trig of the absolute value of this. So I can't remember what this was. Let me do it quickly here. 2 minus root 32 divided by 8. This was negative 0.45. So when you find the reference angle, remember it's inverse tangent of positive 0.45. Okay, don't use 0.45. Don't use the answer button on your calculator. So you get the reference angle of 0.43. Because we can find A5 because it's in quadrant 2. So A5 would be pi minus 0.43, and that's 2.71. That means 2x5 is 2.71 divided by 2 to get x5 as 1.36. Same thing, once you get your first answer, you just either add pi over 2 or minus pi over 2 because that's your period to get the following answers. And we know tangent is also negative in quadrant 4, so I take my 2 pi minus the reference and go 0.43, I get 5.85. Again, if I divide it by 2, I get 2.93. That's the same answer as x6, so we don't need to consider this anymore, because if you just add pi over 2 or minus pi over 2, you just get the same answers as these. Finally, to get the general solution, then you take the first two answers, x1 and x5. So you take those and then plus the period times n, where n is the element of integers. And that is it for this lesson. Like I said, you can see the question is much longer than the one we did in Unit 8. Okay, it takes, quite a bit of space, half of a page, I suppose. But you just got to do it step by step. Okay, it's just some procedure that you need to follow. It's nothing difficult, but it is long. So that means you need to practice, right? Because it's nothing tricky here. You just need to follow the procedure, do a few times, then you get used to it, then you'll be fine. Okay. So good luck with your practice, and let me know if you need some help. Otherwise, see ya.